All right, welcome everybody to yet another Trino Meetup installment. Today we are going to be talking about a kind of interesting use case around Trino, one that I think will kind of span out of what you're all used to seeing in these kind of like more data lake centric and very like um, kind of internal use cases. So today we have Sabin. Hopefully I said that right this time. Sabin Thomas will be joining us today. He's a CTO of Zing Data. He'll tell you a little bit more about the company when he comes on. But basically, they're building kind of a BI analytics tool that goes from your mobile phone. And so I always thought this was like a very neat use case. There's the applications of it may not be necessarily every engineer's favorite, in that you can be reached and constantly have to look at your BI and analytics tools on your phone, even when you're like on vacation or something. But ideally, that's not going to always be what's happening. But if you are in a pinch, let's say you're going to lunch or something, and you need to be able to kind of monitor some feeds or metrics that are coming in, right? And you're pulling that data out when you're mobile and walking around and maybe just kind of working remotely in general. It would be nice to kind of have the ability to tap into all of your analytics that you have set up internally or externally or to a customer, all of these use cases, to be able to kind of visualize that. And what kind of better way to do that than to have a BI tool that's made for your phone, but that can connect to something like Trino that enables you to do like literally cross join analytics and stuff like that, right? All the good things that we have with Trino. So anyways, really interested to there's a lot of like use case like optimizations for this, right? Because you think about Trino as a big data platform, it's like we can potentially be returning large data sets, right? So that's going to across the wire into a mobile phone now. Like the clients are no longer like on a VPN network on some sort of very like local hardware, right? You're probably at least talking across a couple networks to get to that mobile phone. And so there's a lot of kind of design that has to go into making this work efficiently and not really be slow, laggy, and problematic for anybody who's using this, right? So, and analytics these days are just everybody's expectations around them are so high. So real quick, thanks to Starburst, a company I work for, that to host this. Starburst, we'll talk a little bit about what Starburst is for just a little quick second, and you can find and follow and learn more about TrinoDB by following at TrinoDB. You can learn about Starburst by following at Starburst Data. Huge thank you if you can go on to github.com/TrinoDB/Trino and give us a star if you haven't already, and that will give a lot more visibility to the open source project. So a couple ways that you can get involved in the community. I like to start out with these because you're about to hear a really cool talk around Trino, but sometimes it kind of leaves you with wanting something to do. So Anna, if you could quickly post these links so that our fine guests that are watching, tuning into this, don't have to frantically write everything down, and we'll post that into the YouTube chat here in a second. So essentially, all these links will come to you in your way. And Trino, so first thing I want to talk about is the Trino Slack channel. That's kind of I would say the kind of main breeding ground for all of the cool community activities that are going on. Anything from development to how to troubleshoot and use Trino, to just kind of different ideas for projects and things like that are going on. And random chatter. We also have a meme room that is kind of getting a little more activity these days. So we're slowly trying to build up that Slack channel, and it's at, I don't know, is it like 8,500? Are we quite there yet? give me a second. We're at 8,732. So it's quite a few people. Weekly average users are around 700 per week. So it's very healthy, thriving Slack channel. And if you're getting started with Trino, it's definitely recommended to go there. There's a lot of people there ready to help you out and get you started and kind of bootstrap you if you're brand new to Trino. Another good resource is a show that I do with partner in crime Manfred Moser and Cole Bowden. I guess partners in crime. Trino Community Broadcast is a kind of, we say broadcast, but it's a podcast slash video broadcast. That we push to YouTube as well as on a couple of all the main podcasts, Apple and all that stuff. And we essentially just talk about happenings, things that are going on in the Trino community, cover some recent pull requests that were merged, and just give everybody a little bit of a pulse of all the things going on that you can kind of easily digest or listen to in the background. So Trino Community Broadcast is a good way to kind of see what's going on with the community and kind of quickly stay up to speed with like all the cool things. And we do some similar topics to kind of what we do here at meetups and talk about some interesting things. Also, Trino virtual meetups. We have an Americas and EMEA and an APAC group. These are all virtual kind of regional meetup groups. And where we're going to be moving with this shortly is as the world's kind of gotten a little more open to us moving back to kind of in-person events and things like that, we're going to start trying to aim to have more in-person meetups that we will actually be kind of getting the video of and streaming still to this same channel. But you'll be getting to see actually in different types of community meetups that are happening around and let's say in the Americas, in the US, and in the maybe even South America, anything that's aligned on the time zone, right? Basically, you'll be able to see what's going on around the world, right? So if you're in the Americas and there's something going on in that time zone, then that will get broadcast to the virtual Americas side. Same thing goes for EMEA, and same thing goes for Asia Pacific. So definitely, if you're wanting to kind of see as we roll this out more this year of the in-person getting kind of brought into the virtual, this kind of enables us to do both sides, right? Be able to do a lot of the fun in-person stuff in different areas. But then if you're not in that area or close to a big city or something, you can still tune in and be a part of the community on one of these virtual meetups. So definitely recommend join one of those. If you want to contribute to the project, best place to start out to kind of understand what's going on is trino.io/development. It's, kind of the development philosophies, how to get started, and a couple ways to set up your environment, things like that. Similar for blogs and docs. If you're wanting to write a blog, reach out to me on the Slack channel, but you can even go take a look at a couple of the blogs that we've already published this year. And then likewise for docs, you can go to the GitHub repo down there. Oh, and looks like Anna did send out these community resources. So thanks, Anna. So if you go to just, this will be in the chat for YouTube. If you go to the starburst.io/info/trino-community-resources, that'll have all of these links here. It's just one page that holds all these links. So definitely check that out. And thanks for posting that. And you can check out all of these and get to know these. And then finally, the last thing, we do have a Trino forum. It's currently at trinoforum.org. And basically, this is our things that we take from the Slack channel that are, very common topics that are being discussed there and asked over and over again. And we basically copy those out into the Trino forum so that it's something that gets essentially indexed by Google, right? So this is going to be, yet another kind of area that if you're already in the Slack channel and you're kind of pretty active there, Trino forum won't be anything too much new to you. But if you're brand new to Trino and you're Googling things, Trino forum will show up in a Google search now, which will expose some of that information. So that's all the Trino community stuff. You need to know. If you have any other questions, let us know. If you want to get a cool Trino shirt, if you have not done this before, you can, again, this URL down here at the bottom, go to that. That's also contained in the summary link that we just sent you a while back. And thank you again, Anna. So that's go to that URL and it'll have this Starburst.io info America's Virtual Trino T-shirt form. So go to that web URL and then fill out the form, and you will get, your shirt size, that kind of thing, your address, and then we'll send you a Trino shirt if you are in a country that we can send to. If not, we will give you a some form of nice little gift card. And unfortunately, there are a couple countries that we were not able to send to, so apologies for that. So real quickly, for anybody who is new to Trino, I want to do a quick what is Trino, what is Starburst, and then we're going to hop right into the meat and potatoes of this. So what is Trino? If those of you who don't know, Trino is a SQL query engine. And I think that's the kind of big distinguishing factor is when you say query engine, a lot of people are thinking, okay, is this a database? And so it is a database that is essentially lacking a lot of the transaction support. It's lacking a lot of the, kind of indexes and all this storage manager stuff that kind of maps everything going from, the query engine, what the query engine is talking to the actual storage on disk. So Trino is just the query engine element of that. And it's a distributed, very highly performant SQL engine. The problem that kind of that gets people wrapped around is, okay, well then what's the point of just a query engine? So Trino can actually, we'll start out with this go down to this separation of compute and storage piece here. So Trino can actually run queries across multiple data sources. So this last bullet point down here that says federated queries, that is actually saying that Trino is a query engine that can talk to MongoDB, for instance, a NoSQL database, and talk to MySQL and be able to run the SQL semantics of a query over Mongo, as well as the SQL semantics of a query over, let's say, MySQL, which, SQL on MySQL is not crazy, but SQL on NoSQL is definitely kind of interesting, right? And so we start to have just this ability to talk to all these things, but then not only can you just talk to them in the same language, but now you basically, have this translator, right? You can actually join that data in flight as you're reading data from a NoSQL database. You can join that into a SQL database. And so that's really where a lot of this, Trino as just a query engine, is starting to prove its value. You can actually move, kind of get data at your fingertips in the one single CLI without having to move it around and try to get it into one, wrangle it into one location like we've been trying to do for the last, multiple decades. It's open source. It's community driven. It's very so it's Apache licensed. I should say that should be a bullet point there. So therefore, you can make your own fork of it. You can use it for any purpose within your company. Do whatever you need to do. You just can't hold us liable if you change it in a way and it blows something up on you, right? That's Apache license right there in a nutshell. So, and then, being able to deploy, we have Helm charts. We have all these other options like deploying it in the cloud. A lot of people don't know, but there is, the ability to run Trino in like EMR, for instance, or you also have like Athena and these kinds of things that run on Trino. And then we're going to talk about here in a second, I'd say my personal favorite of how to run Trino in the cloud, which is using Starburst. So let's hop right into that. So if we talk then about all these kind of issues that we have. So one particular issue I faced was, actually getting Trino up and running, and really actually not Trino up and running was the hard part. Keeping it running and scaling it up is really where the kind of rubber meets the road. And so Starburst kind of started out as a group of people who were contributing to what was once Presto and now Trino. They were contributing, ultimately developed a consultancy around this, and then built the company up to have like enterprise versions of Trino. Now, in the last couple years, we have made a cloud native kind of SaaS product version of Trino called Starburst Galaxy. And this is by far the easiest and most efficient way to run Trino. It literally has like a huge part of the brain trust of the Trino Software Foundation people working on it and focusing, trying to make it like the most efficient possible, and literally stays very, very close to the open source. It takes away all of that kind of difficulty in actually deploying Trino, maintaining it, and adds a lot of these like cool extra features that are enabling these fancy architectures called data mesh. And so data mesh and even like data lakehouse as well, it kind of interops for both of those, and just gives you a lot of discoverability, state security, and all these extra pieces that just don't come out of the box with Trino. So that's Starburst. And full disclaimer, I work at Starburst, so that's but at the same time, that's ultimately why I'm on this giving the talk, because Starburst is hosting this, right? So again, thanks a lot for Starburst for hosting this. Without further ado, let's hop into the man of the hour, Sabin. Let me pull you up here. How's it going, Sabin?
Pretty good. Thanks for introducing me, Brian.
Yeah. So tell us a little bit about Zing Data before you hop right into this interesting architecture that you have to support.
Yeah, absolutely. So Zing Data is, in a nutshell, simple, social, and collaborative business intelligence with a heavy focus on mobile first. Everything in Zing allows you to interact with it on the web, but we feel mobile first is a kind of a missing piece for the future of work.
Yeah.
Everybody's, through the pandemic, has already been working on their phone. And so this is a natural extension where you can get a lot of your work done and essentially database querying and analytics done directly from your phone.
Awesome. Well, I'm really excited to hear about it. And without further ado, query optimizations for mobile use cases. Let's hear it.
Awesome. Thank you, Brian. Perfect. I think I need to get my slides on there. Okay. Thank you, guys. Thank you very much, Starburst, for having us on. Really excited to talk about our interaction with Trino, with Starburst, and the larger ecosystem. And this is just a great community to be a part of. I think the Slack group has been an immense source of technical content as well. So hi, everyone. My name is Sabin Thomas. Like Brian introduced you, I am the CTO and co-founder at Zing Data. And today's session is going to be focused on what we've run into a lot, which is query optimization, specifically for mobile first use cases on Trino and on Starburst clusters. So just a real quick agenda here about how we're going to go through the material. I'll give you some insight into the type of customers that we've interacted with that are running Trino and large Starburst clusters as well. We'll talk about what Zing Data is and essentially what mobile first means from an architecture standpoint and how we've thought about being able to solve the problems that people who would want to interact with databases have. Then we'll go into the guts of sort of query composition and sort of the considerations and challenges that mobile first use cases bring up. So I think that'll be interesting to dive into how we've thought about those things. That will naturally segue us into optimizations. I think the Trino ecosystem provides a great amount of input here to be able to optimize and fine tune your cluster so you get the most out of it. And then we'll kind of talk about a more recent feature that we've had at Zing Data, which is being able to use OpenAI, and then how we apply visualization inference on top of the OpenAI integration there. So just a really quick aside about me, I'm the co-founder here at Zing Data. In my past, I've done a number of things. I've co-founded two other startups, both in the developer security space. For one, initially focused on how developers could write more secure code, so a lot of syntax tree manipulation, and being able to provide just-in-time analysis of the code that an engineer writes on. And then the other one focused on runtime application security. So I've spent a good amount of my experience focused on how developers think about products, how to be able to best get them to value quickly. And so that's been my past. From a data space, and sort of the genesis of how we thought about bringing Zing Data to fruition was my experience at Rakuten, where I was a director of engineering there. And part of my task there was managing multiple teams that was responsible for the data pipeline for the payment transactions. And even back then, this is when we were using early versions of Lakehouse architecture. This is going back 8 or 9 years ago. Even back then, the access to data was always a challenge. In spite of being able to build really cool architectures and really immense clusters that would be able to query all sorts of data, being able to access it was always still a problem. It was very much desktop focused. You still needed somebody to write a query for you. And so being able to put data analysis and the power of it into the hands of people was sort of why we thought Zing Data should exist. So let's talk about sort of TrinoDB in the field and what we've seen. So at Zing Data, we're pretty fortunate to be able to interact with a good number of customers and who have had different use cases. So we have a full spectrum of use cases. We have one spectrum of users where you have a very small engineering team, no data team per se, somebody who's got some type of MySQL or Postgres cluster and a mix of Google Sheets that wants to be able to access data on the go, wants to be able to look at user information, wants to be able to look at user activity, inventory data, all of it on the go. And the other spectrum where we have users with really large, customers with really large data teams have been able to implement really stunning Lakehouse architectures and still have the issue with being able to access data. And so with Zing, we think we cover the full spectrum here, and it's been interesting to work on these use cases. So one example here that I've outlined is where we've interacted with a Fortune 500 customer here in the real estate space, specifically commercial real estate. And they had a mix of data coming in. We were able to work with their data engineering team. And sort of the infrastructure that they used was very Trino reliant. And if you compare the other query engines out there in the market, Trino gives you the best flexibility here to be able to query multiple data sources, to be able to do sort of in-joins across different data sources from SQL to NoSQL. And so they really saw the power of that. And that was a big part of their architecture. They ran multiple clusters. They had one for doing roll-up queries and roll-up batch reports that they would have scheduled through various times of the day. And their granularity at this point was around every day. I think they were working on getting that to even be an hour type granularity. So that was something that was in process. And there's another TrinoDB cluster that was responsible for being able to run ad hoc queries. And this is sort of the in-the-moment data analysis that their employees would want to be able to query directly from. So with these two clusters, they had a mix of data sources, but the primary data sources that we saw used a lot was these three, which is a combination of static data sources that were hosted on some Google Cloud storage bucket and then sort of transferred from S3 to Google Cloud. So that's another ingress egress that I don't fully understand or would recommend. But this is static data that hosted, that held information about the property that they were transacting on. So attributes of the property, location information, and then just a general non-changing data set that would be held in static data sets. Then they had sort of a Postgres cluster that was primarily their lab interface here, property transaction data. So this company dealt with a large volume of real estate transactions, both in the commercial and residential space. And so with this, the transaction data was ingested and was held in that OLAP space to be able to query that. Along with that, this company also put out reports and market reports, and also had a web portal where users would be able to interact, be able to see a specific property, be able to dive into it to see different transaction information on it. And so we would get web activity that would come through. They did use a Kafka cluster, I believe it was Confluent, that they had deployed as well. And that would be the source of where web activity would come in through streaming. So with these three different data sets, this customer used Trino to be able to query across them to just give them a good picture of being able to understand how transactions are happening, how often they're happening, what's the best way to get competitive info, and what's the best way to orient their workforce towards being able to sell more data, towards being able to sell more properties going up in the future. So with that in mind, and with that data architecture in mind, their needs were quite simple, and it's sort of the idea behind Zing data in general, which is higher engagement of their data. As much as you were able to write a dashboard, as much as you were able to have a data team be able to spend time to create different reports, this ad hoc on-the-go access is still meaningful for people that have to contend with changing data ever so fast. And so higher engagement was a really big need for this company, and this is where Zing Data was able to help them be able to get more broader adoption, broader access to that data, versus somebody who would always be at a laptop to be able to open up a pre-compiled report. And then the query response time and latency with that need always had to be in tandem with that. So Trino offered this to be able to get really good query optimization, to be able to get really good query response time across all these disparate data sources. So just to set the context for what we do at Zing, mobile first and web, we are able to be a fast and collaborative BI tool that works anywhere. And so this ubiquity of access is what we've really thought about. And this sort of necessitates a very different architecture. It's very different thinking about an existing dashboard and sort of transporting that to mobile, in which case it still ends up being very static. For us, we've thought about data analysis on the go, and so the architecture to be able to support something like this is also very different. But let's consider the challenges. When you're thinking about doing data analysis on the go, what are the things that are different about some preconceived notions of how you interact with data? So being mobile first, a small form factor is both a pro and a con. It's an opportunity as well as something to be mindful of. You're not able to work with a 32-inch screen to be able to scroll and endlessly scroll through table data and be able to have a large screen real estate to show different things. And so when you're working on a small form factor, being able to show the most important data for the query that the user has asked it is very important. And so this is where we've really thought about what query composition looks like, how to best structure and morph the query so that the user, for what they're asking, can get that right information quick, and then provide the opportunity for them to be able to filter down later on. So we really believe in this chain of data analysis where you are able to see relevant data at the outset and then be able to sort of filter down if you want to get more fine-grained into it. Other things that are responsible, that are kind of challenges for the mobile first use case, are long-running queries. On a desktop, you're able to sort of run a query on your 1 terabyte cluster and kind of sit and wait for the results to come back when you need it to. On a mobile phone, this is especially challenging. One, given poor connectivity, in some cases, we have global customers in various different countries. Surprisingly, in the United States compared to users outside of the United States, we're seeing explosive mobile usage for things like data analytics outside the United States, where a strong connection is not always a given. So when the user gravitates from 3G connection to 5G connection, and for a query that's in process, what happens and how are we able to accommodate those? Other things from mobile that are pretty impressive is like the amount of data that you get natively. So geolocation information, you get an idea about the operating system that the user is running. You also get an idea of the extent of how limited your CPU and RAM are on a small form factor like a mobile, an iPad, or anything in between. And so this helps us understand how we really need to compose this query when we're running a real large query against a lakehouse architecture. Other things that I've come to realize as we've been working on Zing data have been things that app developers have already known for a long time, which are things like app backgrounding. When you bring up an app to the foreground and then you are working on that, you issue a query and you app background it to go to another query, to go to another app, say for example Slack, to be able to do things, because everybody does that when they're on their phone. Different phones have different constraints on how they deal with backgrounded apps. If you're battery optimized mode, that automatically shuts off all connections. So if you have existing queries that are running, those get immediately shut off and you're not able to poll or not able to get results. And so those are things that we've designed for and architected that we think really well solves a lot of these use cases. Other things are query freshness. If you're on your mobile, and if you bring your app to the foreground, if that's a query that you've run in the past, when you refresh, what's the frequency look like? Do we make sense of where the user is to be able to initiate a refresh? Those are concerns as well that we've thought about. Push notifications. This is a really exciting thing about mobile that you kind of don't get with being on a desktop. You kind of have some flavor of it with WebSockets, but on a phone, you have the benefit of being able to work with the user's notification system to let them know that there are things in their data that are changing, things that they'd like to be alerted about, and you kind of get a more full-featured interactivity model that you just don't get on the desktop. And we think this is where a lot of apps kind of work with, and I think for data analysis, this is also really helpful given that context. Cool. Okay, so just to understand, this is sort of like a high-level architecture that we've thought about here for Zing and really considering these different challenges and use cases. Like I said, it's not the same being able to take an existing dashboard and being able to work that into mobile. You kind of have to start with this from the ground up. So here, among them various different devices, we sort of have an ingress layer that we kind of get incoming requests for data analysis, or we get incoming requests for data queries. We're able to sort of balance this out. We have a partitioning layer and a load balancer that's able to partition this out based on the user's information, based on the type of organization, and then ultimately based on the data source they're trying to interact with. We have different sub-processors as well that look into the query that's being initiated. So things like a dialect parser, if you're running against a TrinoDB versus a MySQL Postgres cluster versus even something as simple as a Google Sheet, we're able to parse and optimize that so our query optimizer logic is dialect aware when it does the tuning that it needs to. And then ultimately, we also have something similar to a Trino cluster coordinator layer where we're able to do query brokering and some federation internally. That gives us the best optimization for being able to deal with a wide variety of users being able to run multiple queries at the same time as well. Cool. Okay, so just to give you a flavor of what the app looks like and how you can interact with it, we have two modes of interactivity. One is sort of this low-code editor that allows you to tap into a table, be able to tap into columns, be able to select different aggregation options like group bys, summations. You can also specify filters. And then there's also a full IDE where you can run your entire custom SQL. You can also initiate various kinds of joins. But in this low-code approach, we think for the user that's semi-technical, this is a really good interface for not needing to know the extent of query optimization that you have to do. And this is sort of the it just works thing that Zing Data brings to being able to do query optimization. Yeah. So one thing that is really important here is, like I mentioned, the small form factor means that you have to show relevant data to what a user is hoping to see really quickly. If I think about the TPCS data, the data set we have on Starburst Galaxy, this is used for high transaction benchmarking as well. If you look at the catalog sales, a typical simple query for being able to looking at the sum of all the sales organized by item SKU would give you this kind of query that you see on the screen here. But if you run this against the 1 terabyte Starburst cluster or a Trino database, that can take a good amount of time. My cluster was not optimized, and so this is me running on desktop, and that took a good amount of time, and I never got it to complete, but it's probably because I haven't done a good amount of optimization. But let's just look at the query in general. There's an aggregation happening, and there's a group by happening, and this is just a simple query where a user is trying to be able to get this information. And so for Zing, being that small factor, being that we want to be able to show the users the relevant data right away, we make heavy use of window functions. And window functions are great at being able to partition data, being able to rank it based on the aggregation metrics that you have. But it gives you quick data, and it makes an assumption based on what the data the user that wants to see. So this allows for sort of fast data exploration. We've taken that previous query, and Zing Data has applied its query optimization to say, for all of the records in my catalog sales collection, be able to rank the sales price, order that by by data there's a subpart of this query that's not visible, but order this by showing me the top 50 of the most expensive items and show me their SKUs. And so here we're able to use inbuilt SQL query functions that give you a quick aggregation of that data rather than having to compute that initial query. Other options that you can use, and these are all inbuilt depending on the ANSI SQL standard that you're working with. There's various other ranking functions that you can use. You can do percentile ranking, you can do entile ranking. And so these are good things to be able to understand, to be able to run against your Trino cluster. We do this automagically with Zing when a user has set up their Trino database and has pointed Zing at it. When they're tapping on different columns or different pre-built queries, we're able to run these optimizations behind the scenes to say, this is what we imagine you were trying to look at. Here's additional filters to be able to select and query them up or down or order them differently. Cool. Other things that we've also have to interact with at Zing has been optimization for queries. And so this is where Trino and the documentations are an excellent resource. Being able to look at a query plan, just being able to run explain or explain verbose gives you a good indication of where Trino is spending a good amount of time and where the underlying data source is spending a good amount of time. And it also gives you information about the connector as well. And so we've spent some time understanding this. We've had to optimize and internally tune sometimes. So we work with the explain quite a lot to understand the query plan. The other information that we get out of a query plan is also how to right size the cluster. Oftentimes we will work with a customer, we will have Zing deploy, and there may be one or two queries that we want to optimize further. And running these query plans gives us information about how to right size that cluster specifically for that use case. So in the example that I gave earlier about a real estate company, for their scheduled roll-ups that they ran on a daily basis, we were able to give them information about how to take care of that based on the query plan. Another thing that's been covered, I believe in earlier Trino meetups, has been things like Trino caching. So Elixir, if you're using the Hive connector, has been pretty optimal as well to be able to not have to spend the load time that the worker nodes have to spend to be able to load in files. This runs if the same query has come through. If you have Elixir deployed, you can get the benefit of in-memory that has already been loaded in for the previous queries. So this is a great use case for static files, and we're running queries multiple times, and we've had the benefit of being able to use that as well. Cool. Another thing that we've spent time on has also been predicate pushdown. And so depending on the connector that you use with Trino, you can have different results and different outcomes. One thing that we've had to work with the previous customer has been a predicate pushdown for a BigQuery database that they had used Trino to front for query federation to. So one example of this is when they kind of ran a where filter against their huge BigQuery table. They found that the BigQuery connector, or at least the materialization of that view, ended up happening in the Trino cluster, and then the where clause would be applied. So the query filter would be applied after the fact. So if you're running this on a 10 terabyte cluster, you can imagine that's a good amount of load that you can kind of deal without. So using the query pass-through, if you're using predicate pushdowns, has been pretty helpful. It allows you to kind of do a query pass-through. So in this case, we've had to morph that previous query to be able to run the query filter directly in BigQuery and then get the benefit of having Trino being able to federate that. So some optimization there. I believe the BigQuery connector may be working on that. I think there was an active GitHub issue to be able to allow for wheres in there. Okay, cool. So the other thing too, and there's great documentation on this that we've worked with about being able to work with join enumeration. So if you're looking at the cost-based optimizations, how joins get run, especially across different data sources, can have different effects on latency. And so being able to deduplicate joins right now, I believe there's an active GitHub issue where they're working on being able to not have to run the join multiple times in the Trino cluster if you're working with the different data sources. So those are good things to be aware of and how to be able to optimize your query to consider. These are things that we ran into, and so these are the optimizations that we applied internally. One thing that is a pretty neat feature that we launched in Zing has been the ability to alert on data. So presuming you have a Trino cluster that is looking at pricing data, you're able to say, send me a push notification when my data changes by this percentage over time. And you can set the granularity to be able to run as much as every hour or even every 15 minutes if needed. We found that query scheduling for these use cases ran into a bit of an issue. There's some sensitivity around how frequent the user wanted to be notified about this data and only when the data changed by a certain amount. And so for that use case, we had to muck around with max runtimes. The scenario here is if you have your push notification frequency set to be run every hour and the query itself takes about 10 minutes to run, your query interval then gets pushed out by 10 minutes. And so to provide that sort of exponential decay in response time, we work with the max runtime to say if the query doesn't complete in this amount of time, we're able to still keep that frequency, and the user is able to select which one of these is more important to them. Other things that we've also changed has been retry policy. So retry allows you to, by default, will rerun the query against the cluster if the query has failed for some reason. If you're running a schedule like some users do, in that scenario, you may not want to retry the query. And so there's different settings based on that. And we've had optimized that for Trino clusters. Check out the Trino docs. They're pretty helpful with giving you good information about how to do this. Cool. And I'll sort of wrap up pretty quickly here. We launched a pretty neat feature with OpenAI where you can, on your phone, dictate a natural language query. So in this case, we're saying, show me support team by topic by platform. This then is able to work with OpenAI. We're able to do some good amount of prompt engineering to understand the schema of the underlying data source and specifically the underlying Trino catalog, and then give us a relevant query that then we query optimize on top of. So it's been helpful to get the benefits of natural language query with such a large language model like OpenAI, and then the work with the result that we get from OpenAI. It's not without fault though. OpenAI does tend to give you a generic result. We've had to do a good amount of prompt engineering to be able to get the right and relevant result. Another big problem with what OpenAI gives back is schema and namespace issues, and so that requires a good amount of simple regexing to be able to add those back in so that you actually get a runnable query that can run against Trino to be able to get those results. Once you get those results, though, we then are able to apply visualization inference. So that we're seeing a multi-group by aggregation that requires a bar chart. That's the best way to visualize this data, as opposed to maybe a donut chart. And that's the inference layer we're able to apply, again, using the Trino optimizations with the sampling and ranking that I mentioned earlier. And that is it. That just is just a quick overview here about how we do things here at Zing Data, how we've really benefited from what Trino has to offer, and then ultimately being able to use the optimizations that comes out of the box, and then also with the different connectors that it offers.
Saban, that's super cool. I think that so real fast, I want to encourage everybody that's on to ask any questions. Could you go back to the slide with the push down and the where clause? Sorry, the where clause outside of the pass through. Yeah,
Yep.
yeah. Okay, so you're saying this where that's in the pass. Oh, okay, so this where is currently this is going directly to BigQuery at this point, right?
That yes. So in this no this in this materialize what I've seen happen, and this may be rectified now, but what I've seen happen is that Trino is running the first part of this, the select and the from, across a really large table, bringing that into the cluster, and then running the query filter in Trino. And so
Okay.
last we were hoping to do is run that where directly on BigQuery.
Correct. Okay, cool. So if you go to the forward, you're saying that this where does not get pushed down to the to BigQuery?
No, this does get pushed down. So
Okay, that's right. Okay,
yeah,
so you're saying right now this is the kind of trap door that enables the push down for now, but you're
yes,
saying you want to be able to do this without having to rely on the full push down.
correct. Yeah. So we had expected for this to sort of work out the box, but this is what we ended up using to be able to optimize that particular query.
Yep. Yeah. This and that that trapdoor kind of polymorphic table function feature is definitely like it's a good way to get you the where you need to be right away.
Yeah.
But yeah, ultimately, like we want when as we're bringing on connectors and as we have more use cases like this, we definitely do need something like that. I was like looking for actually to see if there was a PR for this, as you mentioned the BigQuery and where, and I wasn't able to find anything. But you do think that there's one that's open, or do you happen to have it?
I saw a relevant issue, but maybe I'm missing out the PR. I think let me check on this. Yeah, I'll send that out. I think thought there was like the recommendation was to use the pass through for now, and
Yep.
my expectation was that at some point the BigQuery connector would be able to work with specifically where's at least.
Yes, that is absolutely like in general that's the case, right? So we have quite a few connectors, and there's always going to be a varying level of push down support as well as just various different supports, especially from the performance perspective, anyways.
Yeah.
So BigQuery is. I'm not saying it's real, but there's a lot to be kind of desired still in the BigQuery connector, from my opinion. And there's a lot of PRs that are consistently going through, making it better. In fact, I just saw a couple that are going out in the next release that's about to go out, fixing a couple syntax things. And so,
Awesome.
so getting these like push down things, I think are it's always the way to kind of like get that natively done. But having this kind of trapdoor PTF as a kind of an initial way to go about it is a newer feature that came later last year, but it's definitely a very kind of useful one.
Yeah, and I think
Sure
and I
that
just
you.
found it.
Oh, go ahead.
The issue is 12346, and I think the optimization there is to be able to support timestamps at least. Where
Okay, but there's not a PR that's
I
associated with that yet.
that's correct. I don't see a PR, and it's an open issue at this point.
1, 2, 3, 4, 6. Let me just bring that up real fast on my end. Looking here, yeah. Okay, so this looks like, and this was even opened by Yuya or mid last year.
Okay.
He's actually been the primary maintainer that is focused on BigQuery at this point. So likely he has this on his list of things that like he needs to work on.
Awesome.
So this is good to know. I'll forward this on to Yuya that you all are looking for this.
Perfect. That'll be great.
So very cool. I think it's always kind of like a where do we focus first, and so getting this kind of feedback is always very good. We got a thank you from TKA Dato, and so I'm not sure if that's like part of your last name or not. Carado, maybe T Carado. Anyways, thanks for watching, and if anybody else has any other questions, I think that was my main one. I was actually like when I first heard you talk about the where clause, I thought you were saying that wasn't getting pushed down with the PTF. I was like, I feel like that's like just directly going to
yeah, no, that's that's the optimization we landed on. Yeah.
Yep. Okay, that makes more sense now. Yeah. So it's unfortunate that you had to kind of like live it with that for a second, but it's like we will definitely try to make that a priority. And I think like if we have enough, especially if you can get a couple people like complaining about it, not to complain about it, but essentially like talking about it, that's usually enough to get one of the maintainers to go look at it very quickly.
Okay, got it.
So yeah, that's usually the most effective strategy. If anybody that's watching this now, just try to get find at least like one or two other people that are looking for this feature, and then have them all like yeah, there you go. I saw the thumbs up that just came through.
Yeah, that's it.
So yeah, get enough people like thumbs upping something, and then that's enough to like get us to be like, oh, okay, we should probably pay attention to this. We just had that another thanks coming through. So thanks Viduni for watching. And let me see. Oh, awesome presentation. Love Taha Kadado. Okay, thank you for helping me out there, Taha. I was trying to make sure I just didn't. It's hard to kind of like pull people's names out, but you
from the username. Yeah, thanks so much, Taha. Appreciate the comment.
Yeah. So it looks like we're not getting too many questions. I mean, I'm definitely like, this is exactly the kind of presentation when I was reaching out to you to ask about this. Like, I'm very
sure thing, yeah.
by this. There's a lot to be considered about making the optimal performance around these mobile cases, right? And so, yeah, as we've heard from a couple other folks here, interesting use case. And so, I'm very I was very intrigued by this as well. So if anybody else is trying to do something like where I don't know, you have like clients in a whole other region, like I feel like a lot of this applies to you too, right? Like when you're trying to do cross cloud or trying to do like multi-region support for like let's say an international company, like I feel like these same issues apply. I was working at a company where we got the luxury of like anytime you were doing analytics, like you were expected to do it within the same cloud region. And so like that was last time I had that, like we had a very simplifying assumption there. So I think this makes things just ridiculously hard, and you can't like live in the lap of luxury of like, it's on the same network or it's on the same VPN, right? So it's going to work fine. So
you can't rely on your 100G connection to be able to run that. Yeah.
yeah, exactly. And you also brought up another good point about like the people who are on a less reliable connection, right?
Yeah.
You don't just have, and even in the States still, like we're all like getting on 5G and all this stuff, but like you'll get into certain areas where you're roaming if you're like in any of these like more rural areas, and you're just as screwed, right? To be able to do that. And with the work from home culture, it's this type of workload or workforce is going to be workload. I was trying to say is going to be a lot more common, I believe. So
100%. And we've seen different things to even expect when a person shifts their connections, right? So 5G, for as prevalent as it is still spotty in some cases, and so there's an automatic drop down to 4G. In those cases, when a query has been issued, for us to be able to understand that the user has lost connection and to be able to then initiate a push notification to say your results are ready, here's a deep link to be able to dive into it. That's a whole different architecture that we kind of have to lean on, and then Trino helps us with that from a latency perspective as well.
Yeah, very interesting. And like, so online is taking a whole new meaning here, right?
Yes.
Like, online analytics are like, it's like getting that stuff critically done, but then like if you lose connection, like what happens? Yeah, these are all very difficult and interesting problems. So anyways, thank you very much for your presentation, and talking about this today is super interesting, and I hope to hear more from Zingdata. So if folks like want to get like more information about like if they're wanting this at their company, or they want to kind of they're interested in just the use case, how do you get, like, is there an easy way to get started with Zingdata and just play around with it?
Yeah, absolutely. So for free to sign up, you get the benefit of a good number of functionality out the box. Zingdata.com.
Where do I go here? Is it
just Zingdata.com? Yep.
Data.com. Okay.
And then there's a login button on the top right, or you can sign up there. Just set up your account.
And you have free tier and all this stuff?
Yep. It's there's free for up to 10 users.
Okay.
Beyond that, we start charging, but it's practically minimal compared to the other vendors out there.
Cool.
You can interact with it completely on the web, or you can even go to the App Store and like pull those down and work with it there as well.
Awesome. Yeah, maybe at some point we can do a little like quick tutorial or something like that, just to so that you
Totally.
can kind of see it in action or something like that. Or do you all have like a kind of like video that kind of shows people how to get like started and what the user in? Because sometimes people don't want to sign up until they see what they're getting. So it's kind of, is there a video that we can point people to?
Yeah, absolutely, and I'll send that out. So basically, in the YZing on that homepage itself, or on the docs.getzingdata.com, those are good use cases there around how to be able to interact with it.
Cool.
There's some hero images on the homepage itself that shows you what the main screens look like, and the other link there is docs.getzingdata.com.
Okay. Cool. Very good. Thanks a lot for all of this, and really excited that this is you're enabling Trino at everybody's fingertips as the marketing.
That's right. Only vendor to do that.
Term slogan for you all.
That's right.
So yeah. Excited for that, and I'm intrigued to see if the community starts jumping on and using this, and obviously let us know if there's any PR that you want us to hop in on. We'll try to do our best to kind of help and support you. Anything else you want to share with us before we hop off?
No, just love the community. It's a great community, and I think we would love to be part of it. So.
All right. Thanks, Sabin, and have a good rest of your day, and have a good rest of your day, everybody else in the community.
Thank you, guys. Bye.